Okay, this last video for today will finish up the last two pages of 6.7, page 11 and page 12. In this section, on this page, we will be learning how to solve when radicals are on both sides of the equation. So anytime you have a radical on both sides of the equation, you always want to isolate one of them. I always tell students isolate the busiest one. Here they're about equally busy, but like if you look at this first example, this one's busier than that one. So I would isolate this one and bring that one to the other side. So when there's not a choice, you know, like this, you can isolate either one, but when one has more things underneath, get it alone and then move the other one to the other side. So let's work through this example. So we have two radicals, so we need to isolate, and it makes sense to take the negative one and put it over to the other side. That makes it positive. So anytime you switch sides of the equal sign, it becomes positive. This one's extra easy because there's no other numbers outside. But once we get one of the radicals isolated, then we raise both sides to the power of the index, just like we did on the previous page. But because this one has cubes on both sides, there's not really any work to do except to solve the equation. So these undo each other. You get 3x plus 2 equals, and these undo each other, so we get 5x minus 6. Then we subtract 5x from both sides, and they did this in one step, but so 3x minus 5x is negative 2x, and then we want to bring the 2 over here, so we subtract 2 from both sides, because remember, everything with an x moves to the left. That's why I did the opposite. Got negative 2x. Everything without an x moves to the right. So again, I'm going to do the opposite. Subtract 2, and I get negative 8. Then we divide both sides by negative 2. So our potential solution is x equals 4. To check it, we plug 4 into the original problem. Excuse me. So don't plug it into this one. You have to go into the original. So 3 times 4 plus 2, cube root of all that, minus 5 times 4 minus 6, cube root of all that. Does that equal 0? That's our question. So this is 12 plus 2, cube root of 14. This is 20 minus 6, cube root of 14. Anything minus itself is 0. So since that is a true statement, 0 equals 0, we can then say our solution set is 4. So not only is that a potential solution, it is the solution. So number 5 is just like number 22 on your test. So let's go ahead and work through that one, and you're going to see it's a little bit more involved than the one above. And how you can tell is when I go to add this over, not everything's under the radical like it was here. It's really easy when both sides are under the radical. But when we have part of it under the radical and part of it not, then it gets a little more complicated. So step number 1. Isolate the most complicated radical. Or the busiest radical. That's an easier word to write. Isolate the busiest radical. So the one with the most things underneath. So I can see right here, this has more things underneath than that one. So I want to leave that one on the left and move everything else to the right. So I'm crossing the equal sign. To cross the equal sign, we have to do the opposite, so we would add radical x. Now don't put it underneath the 4, because it's not a like term with the 4, so write it out behind it. The opposites cancel. That's the whole reason we did that. And we end up with square root x plus 4 equals, I like my x term first, so I'm going to write square root x, and it's positive, and the 4 is positive as well, so plus 4. So this is where students tend to miss this problem, so be very careful with this next step. I have my most complicated or busiest radical alone, so now I need to undo it. So to undo it, I have to square both sides. Like I said, square both sides, not square every problem or every term, square both sides. So hopefully you recognize this as a FOIL problem like we did on page 10. So this and this undo each other, and that's because everything's under the radical. So I just get x plus 4. But on this one, I can't just cancel that because I have the 4 there too, and I'm not allowed to distribute. So anytime there's two terms, I have to write the problem twice and FOIL. And that's why before break we did problems like this with foiling so that we would be ready for this section. So x plus 4 equals, so foiling, we get square root of x squared. From outer, we get plus 4 radical x. From inner, we also get plus 4 radical x. And from L, we get positive 16. So you should notice we have some like terms here. And no, they do not cancel. They don't have different signs. They have the same sign, so we need to add them. Plus, this one can be simplified. So let's go ahead and simplify. X plus 4 equals square root of x squared is x. 4 rad x plus 4 rad x is 8 radical x plus 16. And so you'll understand why this one's a lot of points on the test, because notice we have a radical again. So we're back to step 1. We have to isolate the radical and start the problem all over again to get this new radical isolated. And we're not going to do this second one, so I'm just going to cross it out so that we can use this room here. So let's write our new problem here. And I always tell students, if you have a different colored pen or pencil, this would be a good time to use it. So following step 1, I need to isolate the radical. So I circle it, and this is what I say to myself. Everything moves over to the other side except for that circled part, because I'm trying to isolate that, so anything on the side with it needs to move. So this would be minus x, or you could write minus 1x. And then when you go over here, write minus 1x and put it underneath its like term. Then I need to move this over there. Since, again, I'm crossing the equal sign, I do the opposite. And I get negative 12 equals 8 square root x. Because 16 minus 16 cancels, 1x minus 1x cancels, 1x minus 1x cancels to become 0. So this is my new problem. So I haven't quite isolated my radical. Let's go ahead and flip the equation over. I like to have my x on the left. So how can I get that x alone? So I say to myself, what operation is it right there? Oh, that's multiplication. So to get it alone, I have to do the opposite, which would be divide by 8, divide by 8. So 8 divided by 8 is 1. So we get square root x equals, I can see these have 4 common, so let's divide both by 4 so we get a nice simplified fraction. So that would be negative 3/2. So now notice my radical is isolated. So now I'm ready for step 2, which says undo the square root by raising it both sides to the power of the index. So this is squared, this is squared. So as we said earlier, these undo each other. So now we get x equals negative times a negative is positive, 3 times 3 is 9, 2 times 2 is 4. So that is my potential solution. So am I done? No, I'm not, because it has an even index, and everything with an even index has to be checked. So I need to go ahead and check that. I think we have room for a check over here. So for the check, I write the original problem. And this one you'll probably want to use your calculator for to check it. I'll show you how to do it on the calculator. So let's write the original problem. So x plus 4 minus square root x equals 4. So I just copied the original problem from above. Didn't change it, didn't move anything from side to side. I copied it exactly how it was. So some students like to put these in fractions, but decimals, but decimals are really hard to take the square root of. So I would keep it in fraction form and just use the fraction button on your calculator. So now let's go ahead and put 9/4 in place of both of these x's. So I want to know, does the square root of 9/4 plus 4 minus the square root of 9/4, does that equal 4? And like I said, this is all going to be done on the calculator, so yes, it looks ugly, but we're going to be able to do it on the calculator. So go ahead and get your calculators out. And I'll show you how to type it in. So the square root button, remember we learned, is above the x squared key. So we're going to do, since it's above, second x squared. And then we're going to do 9 fraction bar 4 plus 4. And remember how someone asked in class, do we have to close the parentheses? Well, on this one, because there's 2 terms underneath, you have to close the parentheses or it'll give you the wrong answer. So close the parentheses to tell the reader, or tell the calculator in this case, you're done with that. Then do minus, and then do second square root, 9 fraction bar 4, close. So now if you look, you can use your left and right arrow key. It should look exactly like this line. So 9 fraction bar 4 plus 4, close the radical, minus radical 9 fraction bar 4, hit enter, and that gives me 1. So does 1 equal 4? No, it does not. So what do you think I'm going to write for my solution? This one's invalid. Is there any other one to pick from? Nope. So we write no solution, either using the no solution symbols or the empty set, or you could actually write the words, whatever works. You'll be taking computer tests for the rest of the semester. And so you have to do whatever the computer says. I'm not sure which one of these it wants, but if you do your homework, you'll know by the time test comes. As you can see, this is quite a long problem. Doing it this one time is not going to teach you. You need to work very hard on 6, 7 homework, because there's 2 long ones like this on the test. So very good one to study, and it matches up, like I said, to number 22 on the practice test. You can see it looks very much like it. It has radicals on both sides. So at the end of the lesson, in this video, I wrote down which ones you should do on your practice test after this lesson. Okay, let's go ahead and turn over to page 12. So 2 more problems. Again, this is calculator, so you'll want to keep your calculator handy here. So Gabriel dropped his phone from the edge of a cliff. He heard it strike a rock and break to smithereens at the bottom of the cliff 3 seconds after he dropped the phone. So anytime we get numbers like that, we know that's going to be important for later. Gabriel knows that the time t in seconds, so anytime they give us time, we put it in for t. For a free-falling object to fall, d is feet, uses this formula. So t is time, d is distance in feet. And notice that's all underneath the radical. So now we have to look at the number we're given. We're only given one number in this problem, and we have to decide, is 3 seconds time or is it distance in feet? It's time, so we put the 3 in place of t. And then we're just simply solving this radical equation. So again, I like my radical on the left, so I'm going to flip it over. Make sure you keep that 16 underneath. And then I follow the steps for solving a radical equation. Step 1, isolate the radical. Does everyone agree the radical's already isolated, nothing's outside? Step 2 is raise both sides to the power of the index. The index is 2, so I raise both sides to the second power. And then on the left, the 2 and square root will undo each other, so we get d over 16 equals 9. So now you have to use your knowledge from chapter 6. Anytime I'm solving a fraction, I have to do the opposite. So what's the opposite of divide by 16? Would be multiply by 16, right? So multiply by 16, multiply by 16. We called it multiplying by the common denominator. So the reason we do the opposite is so that will become 1. And we have our d alone now. And so we get d equals, and type in our calculator, 9 times 16, and we get 144. And remember, every word problem has to be labeled, and that's why we highlight things in the directions to help us with the label. So we look at D, and it says D is in feet. So we put feet, 144 feet. So if I asked you to write a sentence for this, you would say, after 3 seconds, the phone has fallen 144 feet. Okay, ready. Oh, how high is the cliff? The cliff is 144 feet. Number 8, similar kind of problem. The velocity of a free-falling object is given by the equation v equals square root of 2gh. V is measured in feet. Let me get a brighter color here. V is measured in feet per second. It's velocity. G, the force of gravity, is 32 feet per second, or 32 feet per second squared. And h is the height. And notice they didn't give a unit on height. I've had students in the past go, oh, how do we know what height is? Well, you can tell right here. They're telling you velocity is feet per second, so you know height is also going to be feet. Okay, so let's read the next sentence and see what information they've given us. So the velocity is 100 feet per second. So that is what letter? Velocity is V. So there's my V. Estimate the height from which it was dropped. Round to the nearest hundredth. That's important. So that tells us it's going to be a calculator problem. So let's write our problem. V equals square root of 2 times G times H. So we know that we can only solve if there's a single variable we don't know. So that means 2 of these 3 letters have been given to us. So let's look and see which one. So I look here and I go, oh, they gave me V. V's 100. And they also gave me G. G, the force of gravity, is 32 feet per second per second. And we just plug in. So the problem sounds scary, but they're really just plug and chug. Then you have to solve your radical, of course. So this is my new problem. 100 equals square root of 2 times 32 times H. So let's flip it over and we get square root 64H equals 100. So the minute I see I have a variable underneath a radical, that tells me that I need to follow the steps from the previous pages. I'm solving a radical equation. So to solve a radical equation, we have to undo the square root, and I'm allowed to do that right now because see how my radical is isolated? So this is an imaginary 2, so I'm going to square both sides. And so as before, the square and square root cancel. So then I end up with 64H equals 100 times 100, which would be 2 zeros and then 2 more zeros. Or you can just on your calculator do 100 and hit your x squared button. So I just hit the x squared button right there. And that gives me 10,000, which is exactly what I have here. So now I need to solve for H. We're one step away. This is times, so I do the opposite divide. So H equals, so in your calculator, 10,000 is already stored there, so all you have to do is hit divided by. And I always have students ask, how do you know whether to do divided by or fraction bar? Well, this is the key. When it says round, that means you're dividing because you want to round what the calculator gives you. So 10,000 divided by 64 is 156.25. So nearest hundredths. This is your ones place in front of the decimal. Tenths, hundredths. Well, there's no number following my hundredths place, so it's already rounded. So this is an exact answer. I don't need to use squigglies. It's exactly what I got, and it's already rounded to the nearest hundredth. So no work needed except a label. So H is height. And right up here we said H is height in feet. So estimate the height from which it was dropped. So we would say the free-falling object was dropped from a height of 156.25 feet. So we finished 6, 7, and you'll notice since we missed 3 weeks of school, we are going to pick up the pace a little bit. We're going to be doing one section a day in order to get finished with chapter 7 before school ends. So we will do 6, 7 on Monday. We'll do 6, 8 on Tuesday. Wednesday will be your day of review. I'll post a video with the answer key and all the problems explained on your practice test. And then Thursday, the week we get back, which would be 6, 7, 8, 9, the 9th, you will have your test. And I'll tell you more about that as that date grows closer. So you are ready to do 19 through 22 on the practice test. That's all the radical equations to solve. And you're ready to do 6, 7 in Connect Math. And like I said, there are 4 questions from this section on the test. So this section's definitely worth your time since it's about 20% of your test, just this one section. Okay.